Hello, everyone. Welcome to the first of many open source data summits to come. I'm Vinoth, and I'll kick off today's event by underscoring how open source is now essential to your data strategy. Thanks for having me and having this, I'm grateful that we have this opportunity to keynote this event. Quickly introducing myself, I'm currently founder CEO at Onehouse, a company building a first of its kind universal data storage that work across all your data ecosystems. And I would like to think I've earned my stripes to talk about open source and open source data by waking up to work on an open source data project for 13 years now. And my background's in data, databases, distributed systems. I've been part of database and data streaming companies, and also been fortunate to have helped some well-known internet tech companies during their hypergrowth phases. So the agenda for today, open source data is a large topic, and we have a ton to cover. So we'll start with an intro to the space, its history, right? Understand the roots of where we are and why we are here. Do a very short technical overview of the different kind of tools and that you would encounter in the open data ecosystem. Discuss a strategy distilled from my experience of watching hundreds of companies do open source data in open source communities over the last decade. And also talk about next steps for today and beyond. So actually, the concept of open source, this form of sharing source code, is actually very old. It dates back to the 1950s. And funny enough, like the reason why people did that was the executable, the binaries were so easy, it's not easy to share them because the processors were so different, right? The open source as we know it today really kicked off with the Free Software Foundation and then open source initiative from the 80s, right? And this is one of my favorite quotes of all time on how to think about open source and free software. Free, it means, free speech as in must to have, as opposed to free beer, which is a good to have thing, right? So we're really at the other end of a 30-year-old kind of software movement, if you will, and standing on the shoulders of giants who have actually laid the path and to get us where we are today. Today, open source has mass adoption, and I believe that's because developers find it super easy to distribute software, and it presents very low barriers for users who just want to try the software, right? You cut a lot of middle layers and interact directly with the users, and it's kind of like a really beautiful software distribution model at the crux of it. And free and open source software around the world today, from your Linux servers to your phones, to your browsers, to even your entire developer ecosystem. Look at how much open source you're consuming, right? And there's an estimated of over 40 million open source developers out there across various open source projects. When it comes to data, my very first app dev stack was kind of this LAMP stack: Linux, Apache Server, MySQL, and PHP. And I was building something like Twitter for my school, right? And Postgres and MySQL, in my opinion, really planted the voice as data flag. They've been around for a long time in open source. And the next wave is when the internet data volumes exploded and sort of we were, coming of age and doing all the social networks. And, so the Hadoop project really kind of popularized Apache Software Foundation, synonymous with big data. Around the same time, right, there was the NoSQL movement, and where it brought about a lot of different open source databases into mainstream. And I was part of one such project at LinkedIn called Walmart, where we were trying to build a distributed database, right? And these were things that kind of set the tone for where open source data is today. And you can see a lot of the open source actually started with operating systems and have been steadily moving up the stack to databases. And now today's ecosystem is amazing, in terms of diversity, right? You have data processing frameworks, you have a ton of open data formats, right? And one of them I've been involved with as well. A bunch of query engines, ways to access your data, a rich ecosystem of, highly performant operational databases that can solve a lot of complex use cases, OLAP engines, streaming messaging systems, data orchestration, workflow management, way to deploy data and control infrastructure, data ops, search systems, ML, AI, data science. It's essentially like a very, very big industry on its own. And there's an undeniable trend towards open source. And open source databases have been steadily, gaining on commercially licensed versions for the last decade. And finally, right, in the last 2 years, you see that they've crossed over. And then the open source market is now, by any, analyst and report that you find out there, it's said to more than double in the next 5 years or so. And we're about to see that open source data is going to be the de facto and the only way to do data and infrastructure maybe 5 years from now, right? So how do we prepare for that, right? We have a lot of power to choose in open source, but with that, there is also a great responsibility to do so wisely. So let's spend some time and understand some of these major open data categories at a technical level, but very, very quickly. So open operational databases, they come in all shapes and sizes. You have your regular battle-tested relational databases that we're all familiar with, right? And essentially it stores data in a single node, and you can have a replica for disaster recovery and things. Then there is like a lot of distributed databases with different trade-offs on consistency, availability, durability, performance. It supports key value data models, document style stores. It's a very rich kind of like ecosystem, but it can store large amounts of data distributed across many servers, right? There's a crop of NewSQL databases, which are trying to converge both, where you can store a lot of data, but with the relation experience. And your specialized databases, metrics databases, graph databases, right? Search engines, search databases, if you will. And a lot of these databases actually have talks that even today, which you should go and check out as well. For many, though, when we say open data, you're thinking probably about a data lake, right? And which is essentially cloud storage and open file formats, data sitting in open file formats on top of it, so that you can do like massive parallel data processing. Super cost effective at scale, no long running servers. So if you don't want to be doing anything with the data, it sits there and all you pay for is storage, right? It's really great for crunching large amounts of data. It's inexpensive long-term storage for all of your organization's data in some sense. And yeah, there have been like huge success stories for this, even dating all the way back to like, 10 years, 8 years ago, like LinkedIn's exabyte scale Hadoop lake that we had back in the day, even, and Netflix famously, was the beacon for the whole cloud data movement, where they built a lot of their stuff on AWS and cloud storage. When it comes to data warehouses, it's really hard to find, open traditional data warehouses that are open. Most of them are proprietary for some reason. And most of the data warehouses out there tend to be essentially repurposed data lakes. So we essentially attach a SQL engine to the data lake, right? That's how most of them are. It has its great benefits. It brings together the same inexpensive storage and all these benefits that you find in data lakes. And, can build now with SQL analytics, dashboards, ETLs, things like this. And there have been like massive success stories on these too, right? Which is, for example, Facebook built all their warehousing needs on Apache Hive during the hypergrowth phase of the company. And then, Presto powers a bunch of different lakes like this, warehouses like this at many companies, like something like TikTok, for example, right? The last 5 years of my life have been about converging the data lake and the warehouse into a new architecture called the lakehouse. And we first originated this during my time at Uber, when we were building out like Uber's data architecture through this new open source project called Apache Hudi, right? So the basic idea was we introduced warehouse-like and database-like functionality to the data lake through like a transaction layer, metadata, table format, a concurrency, like a transactional layer, effectively. Build a ton of data management in open source that you find in these warehouses. They're very good at having well-oiled services that manage your data. SQL support, access to data science, machine learning libraries, ingestion tools. So essentially, we made Hudi the closest thing out there when it comes to delivering a best-in-class warehouse database experience, right? And it's also it's really good, right? Because it unifies your storage across all these different use cases. It can be a source of truth. It can store large amounts of data. So it can be a source of truth for your entire organization's data. And we built the first lakehouse at Uber using Hudi. And it now, even powers lots of data lakehouses out there, including like a Fortune 1 scale of Walmart, for example. Right? If you're more curious about this, be sure to catch the Hudi 1.0 talk later in the event. Another tectonic shift here in open data that I had, fortunately, the front row seats to is stream processing. Right? We pioneered this model back in the day at LinkedIn through the Apache Kafka project. So the basic idea was, instead of processing data in bulk, why not consume data streams and feed them to a stream processor and then build these results, whatever you're trying to compute, more incrementally, right? And then the community has made like immense strides in the last 5 years to handle complex problems like out of order data, late arriving data, and things like that. It's really great for low latency access to data. And if you want like a PubSub system in your company where you want to democratize data, open data streams across your entire ecosystem, this is like a really good model. And you can build event queues, and Kafka's used industry-wide, and there are many other systems like Pulsar like Kafka as well. And for example, Pinterest streams almost 25 GB per second on something like Kafka. And oftentimes you need sub-second query response times, and that needs a different architecture, right? Where the data is local, so that you remove all your cloud storage bottlenecks, you can do like different layouts, indexes. So this is where real-time interactive engines come in, and they're best for fast query response times. They're often used as sinks to your stream processing, processor in the previous slide. And there are, again, fantastic success stories of people using these open data projects at scale at Stripe or Airbnb. So we talked a lot about these different data infrastructure systems, right? Databases, if you will, of different shapes. And on top of this, the world's now doing very interesting things with data, right? They're broadly, data science, where you want to like model and explore your data using code, like Spark and Pandas, like all these different frameworks come to mind when you think about this. There's machine learning, where you're training machines to act on data and respond to things in the real world. Prediction systems, relevant systems, right? These are things that are being built predominantly on structured data so far. There is also like deep learning on images, videos, and you probably would have seen a lot of videos around how self-driving cars are being built. And the breakout technology of this year is around AI and LLMs and NLP. So there is going to be like a lot of different use cases. We are at the very start of kind of this open data and democratizing access to this of same data, different use cases here, right? So we plan to write and expand on all these technical breakdowns a lot more over the next few months. But for now, right, what we established is open data is growing, and there are great options here. And how does one meaningfully adopt them with a winning strategy, right? And let's talk through the challenges and how you can think through this and deliver value for your business. There are challenges to adopting open source, right? It's like everybody wants to hand build their own house. At least I do. It can give you great joy, but it's a ton of work, right? And it's important to understand these challenges before like jumping right in. So a lot of people struggle with integration pain with open source. You'll probably hear this, right? Open source projects are typically good at solving 1-2 specific problems, but it goes back to the nature of how they're born. And you often need 2-3 of these projects to integrate it to solve an end-to-end business problem, right? And you need to take these projects and customize it to your internal infrastructure, right? Which brings us to ease of use. So open source projects are actually built for this kind of flexibility, right? That allows you to customize. But then you need to actually take it, understand it, and for you to operate it in a painless way, you need this learning curve, right? And of course, you need support when mission critical things break, and like help adopting this and training your team, maintenance, security upgrades, and all those things. And these are things that we've seen people go through with open source for the past 4 years from the Apache Hudi community. Let's discuss 4 steps you can kind of take to more carefully consider how your strategy around this, right? So step 1 is understanding costs of build versus buy, right? So even Tony Stark and Iron Man, like with all the infinite resources at his disposal, knows where to build and where to buy. So, he builds his suits, but kind of buys his weapons, right? So there's an opportunity cost to building everything in-house. So ask yourself, would your teams be rather doing something else more valuable, right? Consider not just the initial build cost, but also maintenance, right? And when it comes to costs, you can actually get it wrong two ways. You can either like overlook buying altogether, since you thought open source was like super easy to get started, right? And we see this with like data lakes all the time, but like the first 10 tables are really fine. But what if you get to 1,000? You need a platform, right? So the other failure pattern is, well, you can rush into buying something without like kind of considering true costs. So it's careful to consider both sides in a balanced way. And end of the day, you need to meet your business needs. So whether you pick build or buy, does it match your time to market? Does it meet your deadlines? There are, again, things that money can't buy, which is like, maybe you have regulations that, or, you have a top-down strategy to build in-house domain expertise on something, right? So these are things to consider before, you go in and make this decision. Picking vendors more thoughtfully, right? Using a single vendor for all workloads is like kind of being trapped in the matrix, right? It's going to take you some effort and, to realize your options and realize how we can, come out of it and pick them more carefully. But here are some steps that hopefully help with that. First, understand how the vendor thinks about open source versus closed, right? Many will just promise you here, like, there are a lot of promises on open formats, but maybe the real lock-in is in a catalog or a thing that optimizes your data, right? As a rule of thumb, think about whether you have data in open formats, and also there is some amount of open services that you can use if, the vendor goes away for your own business continuity, right? Should be like a core consideration when you adopt something very mission critical. The best vendors will allow you to mix and match, right? By that, what I mean is like you could, for some workloads, you could be just doing open source, while for some of the part of the thing, you could be buying a managed service. And this helps you DIY this later in-house. Maybe you have a bigger team now and you want to like, bring the technology in-house without doing costly migration. So think about that. And proven commitment to open source, right? And there's like typically a lot of open washing in marketing materials, but really do your homework. Check if they have like, spent a few years in an open source community towards that. Can you influence the roadmap of the open source technologies that they're packaging? Can they contribute fixes, and do they have the track record, right? These things are really important. To the one with the hammer, everything may look like a nail, right? But it's not. Right? There are lots of different tools that can let you do things more efficiently. And for example, like, not doing that has consequences, like for, running a large ETL on a warehouse and keep doing that will just give you like a costly bill, right? And trying to use a data lake for sub-second data processing is not a good idea. And for example, like, if you use like an outdated kind of technology to essentially using cron to schedule your jobs, it's pretty outdated, right? Like, and for example, using like some kind of like a, data format, table format without indexing to, it'll functionally work, but it's going to give you your Spark cluster like a lot to chew on, right? And then increase your costs and latency again. So it's really, really important to consider first what data should fit in what tool, and kind of like do this in a responsible way. Interoperability. Your data should be universal. What we mean by that is, let's say you're doing stream processing on a click stream for your website, and you're also building a hourly report of these clicks. They need the same data, right? So figure out ways to have fewer copies of the data and flowing in a streamlined way to different systems downstream, right? And vendors rise and fall. Just take a look at what's happened in the last 10 years on what the most popular open data engines are, right? So you need to really think about interoperability, because the engines may rise and fall, new technologies come up, and this interoperability is what's going to help you really, make it faster and easier for you to evaluate. For example, like I see graph processing, this bunch of like FPGA, GPU-based acceleration of data, this vector indexes, as you all probably heard about. It's really, really important to keep your data interoperable. And to implement these four things, right? And I can say this as somebody who's fumbled his way through building Uber's massive data architecture successfully, that getting the architecture right matters, and investing that in that early on will go a long way. So what we see is a lot of times architects end up being incidental, meaning like, okay, you follow the market and there's some upfront planning because the needs are unclear, right? And then open source has many choices, like as we saw, right? There are many projects with side-side overlaps, and you need really an architecture that helps ground your requirements, and you can over time swap out technologies as things get better, so like better things show up in the market, right? So this is like a really important thing, and but a thing that people struggle with. So we try to put together like some kind of like a blueprint based on sort of like distilled from our experience. And this is the architecture that I see most large enterprises in adopt around open source data. And it goes something like this, which is, you have your event streams, your databases, all like typically there's 4 or 5 classes of data that you have. Get it into a change capture system, which is open source, like let's say Debizium, right? And then you have it in a streaming storage system like Kafka, Pulsar, and the like. There is like, queuing system like RabbitMQ. There's a bunch of open source options there. And then you're now set up for stream processing also using like Flink and, Kafka streams and Spark streaming and all the various like open source stream processing engines. Then you move this data into what we call a universal data lakehouse, which is the first 2 layers are typically data being ingested and prepared for those various use cases are like BI, MLAI, data science, data engineering, that you see on the right. So decouple that layer from the actual downstream data sets that you create. And this architecture is something that we've seen being proven out at scale by very hundreds of companies in the Apache Hudi community, and they modernized to something like this, right? The reason why they're doing that is it offers some great benefits that you may be thankful for once you do this. First, it gives you freedom of choice, right? No one engine will be good for all workloads. So if another engine shows up, you basically are not moving. You're not building like everything from the source to that engine all over again. That is like super wasteful, right? You can just add another node on to the right, and most of your data just doesn't move. You're just like deriving new data into that new engine, right? And you get a balanced cost performance. You pay where performance is needed, and you kind of like amortize costs where, you can be slower, right? And then this model, we decouple the data management from individual premium engines, and you essentially get to amortize those costs. For example, GDPR, like compliance or clustering or all these data optimizations, you get to do once, and through interoperability, you're able to reap those benefits across your different use cases, right? And you control your destiny, right? Because for most of these things, there are 3 ways to buy this. Either you can build using open source, you can buy from like a cloud service provider, may integrate that into a managed service, or there is a specialized vendor around that specific open source technology. You can swap any of these things out, and you control your destiny in this model. And we need like a streamlined architecture as a result of this, right? Because there is a single entry point. You can ensure data quality, compliance, access controls. It just becomes like super easy to do a lot of these things here. So we're almost at the end of our session today, and let's discuss some next steps, right? I know I've preached a lot here on open source data. So what do we actually practice, right? So what does Onehouse do, and what are we doing around open data? So first, we're great champions for the Apache Hudi OS community. And it's like an amazing community. It's existed from 2017, offering a feature-rich data lake platform that's powering some of the largest data lakes out there. And we are constantly improving open source technology, bringing expanding the cutting edge of what it means to be a lakehouse or a data lake platform here. And we even recently won the InfoWorld Bossy Award for like the most promising projects for this year. And yeah, check us out. And number two, we are also open sourcing a brand new open source project today, along with Azure and Google Cloud right here in OSDS. One table is going to bring cross-format universal interoperability to the space. And we're super excited about that. Number three, our managed solution basically offers open data as a service. Onehouse brings, like I mentioned, this universal data architecture, which makes data open in open formats, open services, interoperable with everything. So we focus more around the data lakes and the data warehousing, and we're just built on all of the open data ecosystem that we just talked about, right? So we're like super passionate about open data. And how can we help you? So, if you're interested in a managed service that needs like, universal data, you can try us our product, email us, or go check out our exhibit virtual booth, and we'll be happy to connect. Or we are crazy about open data, like I mentioned. You can engage with some of our open source communities. You can scan the QR code. You can engage with both of our projects on GitHub. There's more to learn beyond this session. This is an amazing event that we put together today. Thanks to the organizers for having me here to keynote. And if you want more, don't miss this amazing all-star panel later in the day. There's an absolute A list of open data with like the data CEO of Microsoft, head of engineering of Google BigQuery, founders of Confluent and Starburst, two very prominent open source data companies, and the VPs of like Inch from Uber and LinkedIn who contribute a ton to this open data ecosystem. And there are two other sessions, one on one table, from Azure, Google Cloud, and Onehouse around interoperability for data at large, right? And we talk about our vision here. And also check out the Apache Hudi 1.0 preview, where we are unveiling like a database-like experience for Data Lake from the project maintainers. With that, thank you for your time. And here is how we can stay connected. You can find me on Twitter or LinkedIn or email, and have a good day, and hope you enjoy the rest of the day here at Open Source Data Summit.